I'm going to record just because my kids are dying to see all of the stuff that I've been telling them to leave alone. I'm a little bit croaky, so please excuse that. And I should say at the top that there is enough stuff here to talk for days. So I'm only going to show the briefest of introductions, but if you have questions or you want more details, there'll be links to stuff where you can see more in-depth content, and you can just ask, and I'll talk for days on it because I love this stuff. I should start my timer. Okay. So, I'm not even on the right window. Minecraft. This is the first thing we're going to talk about. It's kind of an old game, and you've probably heard of it in some form or another, but you may not have played it yet, or have kids or family members who have played it. It's pretty popular. It's now owned by Microsoft, even though it was invented by a rather disagreeable Swede. And that makes this partially a Microsoft tech stack talk, I guess. In it, you collect stuff. There are some hostile enemies that you can evade. When it turns night, they start appearing, zombies and skeletons and spiders, or in deep, dark caves. But you can turn the game to a peaceful mode if you just want to be creative or do the wacky things in this talk. Right. So rather dramatic shift to a different topic of electronics. I was doing some electronic work a few years ago, and I needed to control a large amount of outputs. I wanted to make an LED matrix, and I went about doing it the wrong way. But what I needed to do was control dozens of little LEDs just based on a few input sources that I had. I couldn't put current on too many wires. I just had to control a large amount of things. And I did some research, and as I said, went about it the wrong way. But what I found was this specific kind of chip called a 4051. If you Google it, you will get the typical little black chip with metal pins on it. And what it allows you to do is to give it 3 inputs, and it will control 8 outputs. So if you put charge on one or more of these 3 inputs, it will output to a different channel. It does that because at the heart of it, it's got transistors. And although this is a very simplified way of thinking about these, transistors are little electronic components. They're like half cylinders with 3 little legs out the bottom. And in a very simplified form, they allow you to control an output with 2 inputs. So it's like an AND gate. If you're at all familiar with programming, using a set of conditions, you can control the output of a statement. And so this transistor allows you to say if there are 2 inputs, if they're both truthy or have charge, then the output has a value or a charge. So you can set up a circuit like this. You can have a battery connected to the 4051 chip, 3 switches, and depending on the switches that you push at the same time, a different output will happen. If you haven't pushed any of them, the first LED will go on. If you push the right-hand side switch, the second LED will go on, and the middle one, the third LED, and so on and so forth. And it's doing this because it's got the transistors inside of it. Now, how it works that out is because those 3 switches you can think of as binary, like they're off or on. And in binary, the number 000 is the decimal 0. So if none of those switches are pushed, the very first channel is active, you can think of. But if the right-hand side switches, it's like binary 001, the first channel gets pushed. Those 3 switches can actually give us 8 possible outputs, depending on which of them are pressed at the time. And that's essentially how that 4051 using transistors can control 8 outputs from just 3 inputs. Okay? So let's look at this in Minecraft. I have made what is arguably a complex looking thing, but in terms of Minecraft circuitry that have been made in the history of the game, it's fairly tame. There's a few things off the top that I need to that I need to share with you if you're going to understand what's going on here. The first is that there is this little dust-looking stuff. It's called redstone. So in the game, deep underground, you can mine this stuff, and it acts like a little electrical wire. I have 3 lines of them. So these 3 lanes of wires that are going in that direction, they're just one line coming from the one switch, and then the middle one is from this middle switch, and then the furthest one over there going all the way down is from this right-hand side switch. There are things in Minecraft that emit power. So buttons do, switches do. So I've got 3 switches here, and if I put one of them on, you can see this line lights up, this line of redstone. That means that channel now has what you can think of as a current flowing through it. In Minecraft, and actually in the real world, when you send power over long lengths of wire, you get what's called attenuation. So the signal strength or the charge drops depending on the distance that it travels. In the real world, it's not as drastic, but in Minecraft, every 14 or 15 blocks, that signal will drop to 0. So I've got these little things called repeaters. They take an input signal. You can see how this, it might be difficult to see, but this gets dimmer. But when this repeater gets a signal, it repeats that signal. So now it's nice and bright again. So I just got these spread out. All they do is amplify that signal again to do away with the attenuation. Now, the 2 most important things to understand what's going on in this circuit, essentially, is that there are things called AND gates, which are these things over here. 2 torches on top and the one over here. It's configuration you don't need to know much about, but what it says is if both of these lines are truly, or if both of them have a charge, then the output will have a charge. It's an AND. In programming, it's very similar to that. In electronics, it's like an AND gate. It's that transistor that I spoke about. And the other thing is this over here, where one block with a redstone torch on, again, you don't need to remember the exact configuration, but this is a NOT gate. So if it has a signal, it will output no signal. In this case, it doesn't have a signal, and so it outputs a signal. Now, using these AND gates in Minecraft and these NOT gates in Minecraft, we can recreate the inner workings of that 4051 chip. That's pretty cool. I've got 3 switches here. You can think of these like the binary switches that I showed in a diagram. At the moment, all of them are off, which means that very first LED is lit up. We can do the binary 001, and we'll see it changes to the second one. Binary 010, which is decimal 2, changes to the third one. Decimal 3, decimal 4, all the way to decimal 7, which is that last channel there. Just using goofy redstone in a game, we've recreated an electronic chip that's pretty common. And so this is brain fuel, right? People have created the most intense electronic circuits and programs and even runtimes within Minecraft. And you've probably seen at some point a screenshot of someone's monstrous redstone circuit. Probably the most complex thing I saw was that someone created an emulator to run games that you could program in a Java-built companion IDE. So you write your program in this Java companion IDE, and then you upload it through memory manipulation to the map that's running in Minecraft, and you can play it on this emulator that is built using redstone circuitry in the game, which is, to me, it's incredible that that kind of thing is done. I've never done anything that complex, but you can probably guess from the ability that Minecraft has for you to build this kind of circuitry, how it's kind of like a sneaky way to potentially get kids interested in electronics, in programming, just from a game that they're playing for entertainment, right? And the market here is massive. It's not just your own family potentially that can do this, but kids all over the world that can be doing this kind of electronic training, just in a game that they can play where they collect little bits of redstone from deep in the earth. I wanted to show about Minecraft. Now, a few years ago, I did a much longer talk about this topic, going through it a little bit more slowly and showing the parallels to programming a little bit closer and some examples of those more complex circuits. So if you want to dive into that, then here's a link. I will share these slides in a channel, or I'll give them to someone who has permission to share these slides in a common channel. And then you can go and you can view this video and get a bit more info on that if this topic interests you. Okay, next one, Lego. So in this house, we build Lego. We love it. And one of the more interesting Lego projects that we have built is this boost set. A few years ago, my son, my oldest now, got kind of interested in just this idea of electronics because he saw me messing with it a lot. And I looked around for an alternative that he could engage with. Electronics is a little bit, it's a little bit volatile. If you don't know what you're doing, you can blow components and you've got to deal with electricity, even though a lot of the time it's just battery power. So it's not as dangerous, but still stuff can go wrong. So I looked around for an alternative that he could use and I found this boost set. Come to find, it's actually kind of expensive, but he had some pocket money and a birthday coming up, so we did it. It's got a really cool programming interface, which I'll show you in a little bit. And this particular set, you get multiple kinds of boost sets now. You get like a Star Wars themed one. This one is just a generic robotics themed one. So you can build this robot dude that's standing up there, or you can build, there's a cat and there's a guitar and there's a little robot making factory, and it's a wonderful thing. If you're looking for a cheaper alternative to this, Lego actually has, that's in the electronic space, Lego actually has a range of things called power functions. You get V1 of these and you get V2. I have kind of a mix of these, but they look a little bit like this. Oh, by the way, if you want to see through the camera, you can hover over my portrait in Google Meet and you can click the little pin icon, and then my face will take the place of the desktop, which I'm not going to stop sharing. So do that, and then you can see these things close up if you're interested. So the power functions look like this. I mean, here's a switch, although I've chopped the end off of it. There's a little motor, and this connects to various Technic pieces, so you can drive things, and it's got a little power connector here. There's the old style AA battery pack with a little two-way switch on it. Again, this common connector for power functions V1. Here's a power functions V2 battery pack. I think it's the same design as the V2 one, but I think this is still a connector for V1. So anyway, it's a rechargeable battery pack, and it's got, yeah, you connect this to stuff. And here's a little infrared remote. Now, I actually have batteries in these, and the reason for that is that you get Technic sets that have these power functions built into them. So I've got a few of these, but this is sort of the first one that I got. It's got a little, you can see the battery pack at the bottom, and there's a motor down there, and there's a motor up there, and here's a little infrared receiver. And so you can put batteries in this, and you can control it with one of these. The infrared receiver, it's a little difficult to show this part, but that orange button over there, it's a channel selector. So you can select one of 4 channels. You can do the same with a control. So you can drive around 4 of these at once, or you can control the same thing with multiple infrared controls if they're on the same channel. It's a pretty cool thing, right? This is a different looking set, but it's exactly the same internals. There's an infrared receiver, battery pack, there's motors, 2. Yeah, 2. These are more powerful V1 motors, but anyway. Side point. You can also use this stuff to build other utilitarian things that aren't really related to Lego remote controlled sets. A few years ago, we were going camping, and so I got some of these things, and me and my oldest built this little flashlight. There's a couple LEDs in the front there, which you also get with power functions. There's a battery pack, and there's a switch up here. So if this had batteries in, it's you hold it as a torch, and you can put it on and see really poorly in the dark because they're not very powerful LEDs. But it was a fun experiment. And then this is a thing where I took one of those old school wind up music boxes and connected it to some some power function stuff, and you can actually turn this when it's connected to power. I haven't got it connected to power, and it will play music. Please play music. It's kind of slow. Oh, it's not going to do it. Okay. Anyway, that's kind of fun, right? Taking real world stuff and connecting it to Lego and then being able to control it with electronics. These ribbon cables that are attached to them, you can splice onto and connect those to electronics. I'll talk a little bit more about that in just a minute. Okay, so just back to this boost set quickly. The way that you program it is by using a visual programming language that's available on tablets. And it is a modified form of a programming language, a visual programming language called Scratch, an event invented by MIT to be a little bit easier for kids to onboard. You set up sequences of commands, and then they do this. The boost set connects through Bluetooth to the tablets, and so it controls the Bluetooth, the robot set via Bluetooth autonomously. It's pretty cool. The actual version of Scratch is actually quite common today. It's got these kinds of command chains. So you've got event systems going here, like when you click the start thing. You've got control flow, like if and looping. And then you've got imperative commands, like moving a character on the screen, or changing its visibility, or changing the sprite that it's using. And my son is really into this. Despite knowing alternative game programming engines, he is really into this because there's quite a cool community around this, where different kids play each other's games and remix games and give each other feedback, and are quite encouraging. So if your kid's looking to program, this is definitely a good place to start. Community here. Okay, so Arduino. Again, with the electronics thing. This is what an Arduino looks like. It's a little open standard hardware board. I don't know a lot about electronics, and you don't need to be able to use this. The basis of it is that you can take input in, and you can give input, or you can give output to real world devices using this. You can plug this in via USB to a computer, open up an IDE, program instructions on it, and then you can do things like turn LEDs on or off, read input from sensors like weather and temperature, create an entire home automation system. It's pretty wild. And I've got a bunch of these, and I've got a bunch of these in projects to show you. But just before we move too far off Scratch, I wanted to point out that there is this Scratch fork called MakeBlock, and it allows you to program in the same sort of logical process as visual logical process like Scratch does, but it connects to a bunch of different hardware devices like Arduino. So you can learn programming in Scratch. You can get one of these connected to a few things and then program with Scratch, and this will generate the code that gets deployed to this device. And I actually have a project that my son did using MakeBlock with Arduino, and I'll show it to you. Get it because it's connected to a bit of a dodgy power source. So it is this rather ugly block, and it's going to make a noise when I open it. It's a little alarm box. I'll disconnect it from power so it doesn't beep the entire day, and then I'll show you how it works. So at the top over here, there is a neodymium magnet just duct taped to the top of the box. And then on the inside, that little white pad that's taped to the side of the box is a magnetic switch. So when it is near a magnet, it closes the switch. Over here is a little buzzer module connected to the Arduino. And so the Arduino was programmed using MakeBlock to say, when the switch opens, like when the magnet moves away because the box is being opened, then make the buzzer sound. And when it closes, make the buzzer stop sounding. It's a very simple program, but it's programmed using this visual programming language. And my son did it, and I love it. It's great. You don't actually need it connected to a wire power. We had a 9-volt battery and a connector, but the connector broke. So I thought I'd just plug it into a transformer so you can see what that's like. Okay. So demo. Remember this green green remote controlled power functions one car that I showed you, I liked this so much, and I wanted to mess with this so much that I bought 2 of the sets, and you can build them in different configurations. This is like the rover configuration. And on top of this, I have an Arduino and a Bluetooth module and a whole bunch of really cool stuff. Now, I told you earlier you could actually control these sets with these controls. I'm going to put the power on, so you can see there's a little, is it easy to see there? It's a little green light. I don't know how easy it is to see there. But I have this remote set to the same frequency as that infrared receiver. And so I can move the wheels of this. I can control this as an RC car, as it was intended to be made. But then what I did was I got some power functions devices, and I immediately cut them up because I wanted to hack into them, and this drove my wife mad. But what I did was I tied into them, connecting to the same infrared receiver, and then those cables go into this little prototyping board that sits on top of an Arduino. And there's a little chip in the middle there. It's not the 4051. It's a motor controller chip, which, again, filled with transistors, but it does a slightly different function to the 4051. And then there is a Bluetooth receiver attached to that. So there's a little bit of setup on this. It's actually the most complex Arduino thing I've built. Not really, second most. And there's a little bit of work to figuring out how this Bluetooth module works, how you connect to it, all this kind of thing. But what it allows you to do is to use a programming language like JavaScript or like PHP to interact directly with the Arduino. There's a bunch of different ways to program an Arduino, but they come in 2 different flavors, 2 main flavors. One is write the program, upload it to the Arduino. You can disconnect from a computer entirely, and the Arduino will forever run that program. It's like firmware, right, on your motherboard. Another way to program this is using a protocol called Fermata or something similar, which is you upload firmware to the Arduino, you use the protocol on a device, and you can, in real time, send new instructions. So you can reprogram the Arduino essentially using this protocol. What I've done is I've installed Fermata compatible with the Bluetooth receiver on this Arduino. And then I've written some code, which I can probably make a little bit bigger. Oh, not like that, though. What is this? No Windows. Bad. Hey. So I've written some JavaScript code that will communicate through Fermata to interface with this. Let me switch it off and on so that I make sure that I have a nice uninterrupted Bluetooth connection to it. Go away. And I don't want to go too much into the detail of this. Basically, all it's doing is addressing the different pins as they are plugged into the Arduino, and then setting their voltages to high or low. That's essentially how it's controlling this. The details of it we'd probably have to discuss separately. But this program is going to make it rotate or spin. It'll spin one direction, stop for 2.5 seconds, spin the other direction, stop for 2.5 seconds. And so it's a JavaScript program. We can run this through Node. It'll take a little bit of time to connect to the Arduino, and then it'll start issuing instructions to it. So it's going to spin the one way, stop for 2.5 seconds, spin the other way, stop for 2.5 seconds. A little bit difficult to see on camera, but that's what it's doing. And if you want a personal demo, we can do that afterwards. Now, the thing that's really cool about this build is that the Arduino, part of it can be completely disconnected from the rover, and it doesn't stop the rover from working with infrared. It's a totally unobtrusive mod on this Technic set. And that's awesome. Like, I love that. But it's a pretty good example as well of how you can build stuff using Technic. Kids are really into building Lego and Technic, and you can use the power function stuff to show them the basics of integrating electronics and mechanics into Technic, and then you can take this a step further by introducing hobby electronics like Arduino and MakeBlock or any Fermata thing, and controlling it with code. And that's phenomenal, right? That's such a cool way to onboard people into tech. Okay, that's that demo. Now, if you want to know more about this, a few years ago, I did a much longer talk, again, more like an hour, which went into the details of how to do this in PHP. and with different devices, including like a train set that gets remote controlled and more Lego details. You can go and look at that for free at the site. I think you need to register and log in with this, but it's free to do that. I checked the other day. So yeah, if you want more details, you can go there for that. Okay, last thing, game dev. This is all going to be in slides. And I don't have a super amount of time for this, but I thought it would be interesting to look at how attainable the steps are to making a game, and that you can do it in JavaScript. So a few years ago, I did this as a project, ended up being a book, and all of the code examples in this book were actually linked to a live code runner for JavaScript called CodePen. This is where it started. So this is a code window, and then this is what the result looks like. Let's talk a little bit about game dev. In game dev, there's this concept of a game loop. So it's an infinite loop. You can think of that it runs, in other words, over and over and over. And inside that, you do things like check for input from players or change the visuals of the game, and insert game logic here, right? I'm using a library, or then when I did this, I was using a library called Pixie.js. All that this does is abstract the rendering process. So you can talk about things like sprites and FPS and resolution, and that's what that library does. But all of the game logic you can actually do in normal JavaScript. If you're unfamiliar with programming, there's this concept called a class. It's basically a container that associates data about something with behavior about something. So yeah, I'm not sure how else to describe that, but what you can do is you can define this container that is a player, and it has some properties like what the graphic sprite is or what its X and Y position are on the screen. And then you can give it some behavior like animate, and that in this case will get this player character to move towards the right, and when it gets further than the right-hand side of the screen, its position will reset at the left-hand side of the screen again. And that's what this visual thing is doing. It's a bit jumpy, but you get the idea, right? Okay, so that's the game loop. Then we get more complex topics like handling player input. So this is exactly the same player container thing again, but it's got some new properties. It's velocity, maximum velocity, how much it slows down or speeds up. And so now it's also got input, player input. So 37 and 39 are actually just key codes in JavaScript for the left and the right arrow keys. If I click on here and I push left or right, I can move this player around. So that's now taking player inputs and putting it into this concept of a game loop. Next one is collision detection. So when you're in a game, you've got to, depending on the game, of course, but most games have this concept, or a lot of them do anyway, where if you are a player and you've in an environment, there are some things you can't walk straight through, like a wall, because that would be a weird kind of game. So you can achieve this in a game as well by modeling a different container, which has its own properties like how big it is and where it's positioned. And then you can do things like checking whether the two collide. So where did I do this collision code here again? Okay. So you can check where things collide. Now, there are a lot of different algorithms to figure this out, and I don't want to go into detail about any of them, except to say that the simplest one is called AABB, collision detection. It stands for axis aligned bounding box. It's essentially if two squares with exactly the same rotation intersect, then you can use this kind of logic to work it out. And using that logic, we can take our player container and we can now have things like collision detection. I can't move beyond that box because my head's clipping with it, and now my hand's clipping with this box. Right, now how do we use this mechanic of collision detection more interestingly? Well, we can do things like have gravity. So here we have our normal movement. We've also got space where we can jump up. And the floor, in this case, is a container like that box, which has its own collision detection, and I can't fall through it. Because if the floor wasn't there, my player would just fall straight down to infinity, right? Similar logic to collision detection, but now what we've added is that the player is constantly falling down unless they can't because something is colliding with them. We can add mechanics to this, like what happens if you're not always falling, like if you want to climb a ladder. Well, we can add that mechanic too. This has collision detection, but it doesn't stop the player. It just engages a different player state. The moment they collide with a ladder object, they're no longer permanently falling, and pressing up or down will move them up or down the ladder. We've got things like slopes or stairs. So permanently falling, but what if you want to be able to climb a slope? Well, again, there's a kind of collision detection there, but it doesn't stop the player. It just puts the player into a different state where they can't fall through the slope, but they can walk up against it, and that will make them climb. You've got quality of life things like locking the camera. Oh, okay, my time's almost up. Like locking the camera, where when we jump, when we move around, the camera actually follows the player. So this makes the player more engaged with the world, and they don't see everything at once. They just see specifically what's going on around the player. Not that. Where did I stop? Okay, we've got things like projectiles, pretty common in games. A little reticule to show you where you're shooting at, and then a little projectile that goes out. It's kind of difficult to see because it's going so fast on the screen, and the FPS looks like it's jarring on Google Meet. We've got player mobs, so don't do it again. We've got player mobs. So this is a different kind of container, very similar to the player. It can move around, but it's got a fixed path, right? What path does this enemy or mob travel? And then if you shoot at it, what happens to it? Does it go away? Does it have health? That kind of thing. We've got our own health. I kind of want to breeze through the rest of this because it's not super interesting. We've got our own health, so we can be hit by an enemy and we have invincibility frames. We can lose all of our health and then we can lose the game. Okay. And then just sprite animation. So this actually delves. Oh, I did it again. I must remember to click to focus. That's what that message is for. Using this or any kind of animation library, we can have different sprites. So what does it look like when the player's walking and when they're just standing still? It's just loading different images in at a certain FPS, which makes it look like it's animating. But that's basically it. Like these, maybe about a dozen different little JavaScript projects that you can actually view and tinker with yourself. Again, you can find these the URLs for these in the slides, but yeah, you can tinker with these yourself. You can edit them, change that code around, and get into game dev. And actually, because this is JavaScript, get into the tech used behind the websites that we build day to day. Even if you're unfamiliar with it, learning this stuff through game dev will set you up to be able to learn that web dev. More details about this is actually the book that I ended up writing about this. You can get on Amazon. But I just wanted to say that you can also use Scratch for game dev, right? It's not just for that IDE that you do it in. And actually, because I was doing game dev and because my son got really into Scratch and MakeBlock, I wanted to figure out if there was a way to that he could use Scratch to make these games. So first, I took a game concept that I had programmed before. So when I was learning to make games, not in JavaScript, I made this game called Oink Pop. There's apples spawn, you go around and you eat them, and you expand until the piggy goes pop. It's quite fun. Kids love it. I did this in Godot, and that uses a different programming language. It's a whole IDE thing on its own. But then I found a tool which you can find at this URL. I'm not going to show it, but you can save your Scratch game as the SB3 file that it is, that allows you to run it locally, and you can upload it to this thing, and this thing will generate a self-contained HTML file that includes all of the behavior and sound and graphics. So you can get one HTML file, tends to be quite big because it's including sound and graphics, that encapsulates your whole game. And once you have that HTML file, you can do a lot of cool stuff with it. So that same Oink Pop game, this is it also on the App Store, but this is done completely in Scratch. So I recreated the one that I had made in Godot in Scratch, and then exported it through that Sheep Testers tool and put it in capacitor.js and exported that and uploaded it to the store. And you can play both these games side by side. They have exactly the same behavior. You'll notice slight visual differences in the Scratch version because I didn't go into too much hassle to make them identical. But that's it, right? You can make your games in Scratch. You can put them in a capacitor. You can upload them to the App Store. That's awesome, right? And if you're making games in JavaScript, that's already the language of capacitor. So you can make your games in JavaScript, have them in capacitor, upload them to the App Store. It's pretty cool. JavaScript's a really, really low barrier to entry language to do this kind of stuff. You can, for instance, make your game in JavaScript and put it in Electron, which is a desktop app wrapper, and upload that to Steam. I actually have friends who've done that. So they made a JavaScript game, put it in Electron, put it on Steam, and it works. It works. Okay. On this topic, the last game jam, a couple game jams back, I entered, and my kids were having fun in Scratch, and so they wanted to do it, and so they each made a game in Scratch, and then I exported it to that self-contained HTML file and uploaded it to itch, and they entered the game jam alongside me, which was like, so proud of that. You can go on the slides and go play them. They're not AAA games, obviously, because it's an 11-year-old and a 9-year-old, but I'm still super proud of that. So that's pretty cool. I think that's all I got. Are there... Oh, wait, before I go, I can actually show you. So when I was programming this dude, when I was programming this, the library that I was using in JavaScript is called Johnny5. By the way, you can ask me about this afterwards. I can tell you all of the stuff as well. It's got a load of examples. It's Node.js ready. You put your stuff in here, plug your Arduino in, and you can control it. It's super cool. There's that Godot game. There's the Scratch game. Here's the sheep tester thing. So you upload your save file through here, and then it makes that index HTML file. Yeah, I think that's all I have to show you. Are there questions?
Go Sandeep.
Hey, Chris. Thanks for the press. I think it was one of the coolest we've ever seen here. My question is a bit about how to get started, but a more specific question. Say I want to do like some coding and some robotics and Arduino stuff. Usually, I've tried it before. How I stopped is I get to some point and then I don't have that thing available, and then I need to ship it. It takes 2 months, and then I forget about it. So, is there some kind of pack or like essential pack that ships with like the most basic stuff I can combine on the different levels that I can get to get started, basically?
Yeah, so there are 2 places that I know of that are local where you can get the stuff. The best place is obviously, there are a couple of American sites to get this, but the shipping is an issue, and I've had that same problem before. But there's 2 local places. The one in what's that place called with the long road that goes from Tableview to the N1? Anyway, that place is called Communica.
Pardon Island.
Pardon Island, that's right. Yes, that's where. Thank you.
Chris, just a note, Sandeep stays in Mauritius. No,
that's yeah. So, okay. Well, for the South Africans, I'm gonna share this anyway. Sorry about that. I thought you were local. Okay, so for the South Africans in Foreshore, there's a place called Communica. They used to be in Woodstock, very old school place, but they sell Arduino and kits and components. I bought a lot of stuff from there before. And then there's also a place in the northern suburbs called Yebo Electronics, much more expensive, but they have a lot more kits. So that's also a place to look. Yeah, I know nowhere in Mauritius to get this stuff, but there's a really good American site called SparkFun. I've ordered from there before, and they have kits and everything. They don't just have Arduino, they have other hobby electronics sets, boards as well, and the components for those. And they can ship with UPS or FedEx. AliExpress, yeah, that's a good option. But I'd say if you can get stuff shipped from SparkFun, that's the best place I found. Their variety and their support and their documentation is fantastic. This Arduino actually came from SparkFun along with some cool Raspberry Pi kit, but it took weeks, and I had to go pick it up at the airport. And yeah, yeah. Other than that, the Lego Boost stuff is probably easier to come by in the consumer market. Like you can go to a toy store and get some Lego thing that has electronics with it, but it'll take some hacking to get it to connect to an Arduino, and it's expensive.
I think, Chris, just to maybe double click on what Sandeep was asking there, is there like a recommendation on what to buy first? So if we're going to do a shipment, local, international, is there like a bare bones minimum kit that's worth buying of cheap electronics, so that we've got all the necessary things when projects arise?
I don't think there is one size fits all kit that I would recommend. Anything that has an Arduino and some LEDs and some resistors and sensors is a good starting point. But I'd probably have to have a look to see if I can sort of recommend a set of things. I found ones that are like single project specific, which are cool if you want to make that single project. And yeah, I don't know. I've kind of just built up over the years, built up a bunch of stuff.
Cool, thanks. I'm going to just throw him out there, and we'll throw him under the bus now. Niels is going to Mauritius in May, so if you want to sneak something into his luggage and send him a bottle of whiskey, then give him a shout. Thanks, Chris. I think it's a really interesting topic. I think just to add on to some of the answers that you've given so far, there's also RS Electronics. They sometimes a bit expensive, but they have one of the biggest catalogs in the world on electronics for professional people that actually do this for a living, and they ship internationally as well. So RS Online is where you can get it, and they're in lots of different countries as well. So they may be able to ship directly to Mauritius and have quite a decent option, but I don't think they're always the cheapest. Ahmed, you had a question?
No, it was similar, so got the answer.
Okay, cool. Any other questions? All quiet. Did Chris answer all of the questions already? Cool. I think maybe if I can flip it around then, more to everyone else who isn't Chris here. I know a lot of you have dug into some electronics and some programming stuff. I think if we go down the theme of getting people to learn how to program or how to code, learning those basic concepts, I think especially for kids, I'm keen to see if there's any other recommendations out there for things to play with or different approaches to use or resources that might be available. The only one that I've got from an electronic side is Yebo Electronics, which Chris mentioned already. They've got some fairly cheap self-contained electronics kits for different age groups. So if you've got a bunch of kids, that I've done it with my nieces and nephews, and it was quite successful in just building. I think we built some type of Star Wars sound making device. I can't exactly remember what they called it, but they've got weird little things like that, which are great fun. I'm keen to see if anyone else has recommendations on what to do with either kids or people that are being introduced to the concepts of coding.
In the spirit of Minecraft, I suppose, Chris, I don't know if anyone else here has any experience with some of the other more programming-orientated games. So, Minecraft, you can build with using redstone, you can build electronics and stuff, but you can't program in the game. There are things like Roblox. There's a new metaverse corrupted one called Sandbox that, that you actually go and create the games inside the game. There's a separate programming part, and then you play and sell your game inside the game. Do you have any experience with any of those? Does anyone have any recommendations? Are they worth trying out?
I would be cautious about Roblox itself. There's a couple investigative journalists that have done deep dives into some of the toxic stuff that goes on with Roblox, and they're quite exploitative. I can link to that by a YouTube channel called People Make Games. But if you engage with it just as a learn to program and completely not as a engage with community or try and make money from, then go for it. If you get swept up in the make money from programming games inside Roblox thing, it's a bad vibe.
Arman, use your words. You've got a lot to say on this topic, I know. Okay, cool. You're gonna have to just read Arman's messages. He's sick. Cool. Last chance for questions. Otherwise, we're gonna close it early. Any takers? Thank you very much, Chris. I think this was a nice break from just the traditional stuff that we've been looking at. Definitely keen to see where we can go with this more, not just as a team, but like in our own lives with our families and friends and kids and everyone else. I think there's some good inspiration and ideas here for us to take further. So thanks for taking your time, and thank you very much everyone else who joined for the breakfast learning session. It's a nice quick one today, so you can get back into your tickets or go finish off your breakfast. But have a good, productive day, and we will catch you all online.